Okay, so objective 2. Now, how do we build these confidence intervals? Well, there's two parts to a confidence interval. The first part is the point estimate. This is the single value estimate of the population parameter. It's going to be the middle value of your confidence interval, right in the middle. All right. Typically, it's going to be the sample value they give you, but that's later on. Okay. So either the sample proportion or the sample mean. And then the second part is the margin of error. Again, because we don't think that that single value is going to necessarily be true, we have to have a margin of error that goes to the left of that single value and the right of that single value to give us our interval. So again, the margin of error describes how far at most we'd expect the estimate to vary from the true population value, from that true value in the center. Again, when you see at most, that means plus or minus. That means to the left and to the right. And again, that is in C% confidence interval. The distance between the point estimate and the true parameter value will be less than the margin of error in C% of all samples. Okay, so again, C% of the time. All right, so again, the margin of error, very important. It's how far from the true value, from that point estimate we think we are. All right, so be aware of that. All right, so let's take a look here at a visual of how we build these confidence intervals. So again, as I told you, the point estimate is the midpoint. It's in the middle. So here's your point estimate, right smack dab in the middle. To build the confidence interval, this is your sort of, formula. It's the point estimate minus the margin of error. So minus the margin of error and the point estimate plus the margin of error. That's how you get these two values, which builds your confidence interval. And this black represents your confidence interval for the parameter. Okay. So it says we include the margin of error to account for sampling variability. So again, this idea of if I give you a value, right, for the parameter, do I think it's going to be right? It might be right, but it's probably not going to be right because it's very hard for me to guess or find the actual population value. So this margin of error allows for that sampling variability. So if I'm 0.2 off or 3 off, that's what the margin of error is there for, to give me some leeway left and right. Okay, so be aware of that. Okay, example 2. So continue this, how many more steps? In the previous example, we learned that the 95% confidence interval for the true mean number of steps taken per day for all employees at the large company is 45.47 to 84.73. Calculate the point estimate and margin of error used to create this confidence interval. Okay, so the point estimate is going to be the midpoint of these two values. So we're just going to use the midpoint formula or an average formula to find the middle. So to find the point estimate, we're going to take these two values, 45.47, and we're going to add 84.73, and then we'll divide by 2. And I'll show you how to do that in Desmos graphing calculator. Let me take a picture because those are 4-digit numbers that I can't remember without looking at a picture. Okay, so if I go to Desmos graphing calculator, make sure that when you do this, the first thing I would do is open up a fraction. Sorry for the lag in my computer. There we go. Open up a fraction. Boom, there I am. In the top, we're going to add 4547 plus 8473. I know a lot of people sometimes confuse this and subtract. Don't do that. And we're going to divide by 2. And there is our point estimate, 6510 steps. So let's come back to our notes here. So the point estimate, so again, I'm sorry that my stuff disappeared, but it's 6,510 steps. And again, make sure that number is in between your two endpoint values, right? If you were to subtract these and divide by 2, you get something in about the 2000s. That would not make sense because it's not in there. So make sure you add. Okay, and now to calculate the margin of error. The margin of error is the distance between your point estimate and those far values. So you could do it 2 ways. You could take the largest value and subtract the margin, the point estimate, or you could take the point estimate and you could subtract the smallest value. This is an or, not both. You can do one or the other. I don't care which one you do. All right, you'll get the same answer both times. I'm going to do the large one minus the margin of error. I'm sorry, minus the point estimate. And if I take the largest value minus that, I get 1963, and that's steps. And that's my margin of error. So here's my point estimate, and here's my margin of error. And that's how I build my confidence interval. Okay. So again, I'm thinking that 6510 might be the true mean value, but I'm saying give myself 1963 less, so about 2,000 steps less, and about 2,000 steps more. Give me about 2,000 either side, and I'm pretty confident, 95% confident actually, that the true value is inside that interval. All right, objective 3 is coming.